Hello everyone, I am Dr. N.Senthil Madasamy, Associate Professor Computer Science Engineering. Great pleasure for me to welcome you all for this session. In this session, topic to be covered is data center design and interconnection networks, warehouse scale data center design under Unit 3 cloud platforms architecture. At the end of Unit 3, students will be able to explain the design principles, architecture, and the enabling technologies of cloud platform. At the end of this session, the students will be able to understand warehouse scale data center design under data center design and interconnection of networks. Now I am started with introduction of data center. Data centers and supercomputers have some similarities as well as fundamental differences. In the case of data centers, scaling is a fundamental requirement. Data center server clusters are typically built with large number of servers, ranging from thousands to millions of servers. For example, Microsoft has a data center in the Chicago area that has 1 million 8-core servers housed in 50 containers. In supercomputers, a separate data farm is used, while the data center uses disk on server nodes plus memory cache and databases. Data centers and supercomputers also differ in networking requirements. Supercomputers use custom designed high bandwidth networks. Data center networks are mostly IP based commodity networks, such as 10 Gbps Ethernet network, which is optimized for internet access. This figure shows a multi-layer structure for accessing the network, that is internet. Then server racks are at the bottom layer too, and they are connected through fast switches as a hardware core. The data center is connected to the internet at layer 3 with many access routers and border routers. Now we will discuss warehouse scale data center design. Dennis Cannon claims the cloud is built on massive data centers. This figure shows a data center that is as large as a shopping mall, 11 times the size of a football field, under one roof. Such a data center can house 400,000 to 1 million servers. The data centers are built economies of scale, meaning lower the unit cost for larger data centers. A small data center could have 1,000 servers. The larger the data center, the lower the operational cost. The approximate monthly cost to operate a huge 400 server data center is estimated by network cost $13 per megabits per second. Storage cost is $0.4 per GB and administration cost. These unit costs are greater than those of a 1,000 server data center. The network cost to operate a small data center is about 7 times greater and storage cost is 5.7 times greater. Microsoft has about 100 data centers, large or small, which are distributed around the globe. Next, we will see about data center construction requirements. Most data centers are built with commercially available components. An off-the-shelf server consists of a number of processor sockets, each with a multi-core CPU and its internal cache hierarchy, local shared and coherent DRAM, and a number of directly attached disk drives. The DRAM and disk resources within the rack are accessible through first level rack switches, and all resources in all racks are accessible via cluster level switch. Consider a data center built with 2000 servers, each with 8 GB of DRAM and 4 1 TB disk drives. Each group of 40 servers is connected to a 1 Gbps link to a rack level switch that has an additional 8 1 Gbps port used for connecting the rack to the cluster level switch. This diagram shows the layout and cooling facility of a warehouse in a data center. The data center room has raised floors for guiding cables, power lines, and cooling supplies. The cooling system is somewhat simpler than power system. The raised floor has a steel grid resting on stanchions about 2 to 4 feet above the concrete floor. The underfloor area is often used to route the power cables to racks, but its primary use is to distribute cool air to the server rack. The CRAC, computer room air conditioning unit, pressurizes the raised floor plenum by blowing the cold air into the plenum. The cold air escapes from plenum through perforated tiles that are placed in front of server racks. The racks are arranged in long aisles that alternate between cold aisles and hot aisles to avoid mixing hot and cold air. The hot air produced by the server circulates back to the intakes of CRAC units that cool it and then exhaust the cool air into raised floor plenum again. Typically, the incoming coolant is at 12 to 14 degrees Celsius and the warm coolant returns to a chiller. The newer data center often insert a cooling tower to a pre-cooled condenser water loop fluid. The water-based free cooling uses the cooling tower to dissipate the heat. The cooling tower uses a separate cooling loop in which the water absorbs the coolant heat in a heat exchanger. The summary of the session, we learned about warehouse scale data center design under data center design and interconnection of networks. I hope you found this lecture is more useful. Thank you and have a pleasant day.